Look at the badge on your grille. If you bought that car thinking a manufacturer's logo guarantees you 300,000 miles of trouble-free driving, you have been fed a massive lie by the multi-billion-dollar marketing machine. The truth they are hiding from you on the showroom floor is that up to 40% of the vehicles riding on a legendary reputation are actually mechanical time bombs, quietly costing unsuspecting owners thousands of dollars in premature repairs. We are taught to believe that a brand inherits its reliability across the board, like some kind of corporate DNA. It is a myth. In reality, a brand's bulletproof reputation is usually earned by a tiny, elite handful of models engineered decades ago. The rest? They are just riding on the coattails of that legacy, using cheapened components and rushed engineering while you pay the premium. I see it every single day on the shop floor. A vehicle rolls in on the back of a flatbed with under 90,000 miles on the odometer and a completely shredded drivetrain. The owner sits in my waiting room, stunned, holding a repair estimate that looks like a phone number, repeating the same phrase over and over. But it's supposed to be reliable. The dealerships do not want you to know that the engineering underneath that shiny sheet metal has radically changed. They want you to buy the badge, sign the financing paperwork, and leave before you realize you bought the automotive equivalent of a Trojan horse. Today, we are tearing down the corporate facade. I am going to expose the hidden mechanical flaws that the manufacturers pray you never find out about, naming the specific engineering disasters you need to run away from, and revealing the true legends that actually deserve your hard-earned money. Let me take you back to last Tuesday. A regular customer of mine, let's call him John, brought in a highly rated, incredibly popular sedan that he bought used for his daughter. He thought he was making the safest, smartest financial move possible. He told me the car was running fine, but it seemed to be dropping oil quickly between service intervals, even though there were absolutely no puddles on his driveway. I pulled the dipstick, and it was bone dry. There were no warning lights on the dashboard. No smoke out the tailpipe. Nothing. When I dropped the oil pan and pulled the pistons out, the problem was staring me right in the face: the oil control rings. The tiny metal bands designed to scrape excess oil off the cylinder walls and keep it down in the crankcase were completely seized up with carbon. Instead of sealing the combustion chamber, these poorly designed rings were allowing the engine to literally drink its own lifeblood, burning through a quart of oil every 1,000 miles. Here is what the manufacturer won't admit to you. They knew about this. They designed these engines with tighter tolerances and cheaper materials to hit strict efficiency targets, sacrificing long-term durability in the process. And because the dashboard oil light is programmed to only trigger when fluid pressure drops to a catastrophically low level, the system essentially waits until your engine is already destroying itself before it alerts you. John's engine was starving for lubrication, grinding metal against metal at 3,000 RPM. A car that should have easily sailed past the 250,000-mile mark was completely junked before it even hit the midpoint of its expected lifespan. If you are shopping the used market blindly, you are playing Russian roulette with your bank account. But it gets worse when you step into the world of modern efficiency. The system loves to push the narrative that complex technology is always better for your wallet. Take a look at the larger, family-sized variants of highly praised hybrid models. The standard hatchback version might be a mechanical marvel, but when the product planners decided to stretch the frame, add a massive cargo area, and market it to families, they made a fatal compromise. They left the exact same hybrid powertrain under the hood to haul around hundreds of pounds of extra dead weight. Think of a hybrid battery like a physical bucket. If you ask it to carry a normal load, it lasts for years. But when you constantly force that same bucket to carry a double load up a steep hill, the internal components sweat. In these heavier models, the individual cells inside the high-voltage traction battery degrade at an accelerated rate because they are permanently under maximum stress. When those cells fall out of balance, your fuel economy plummets instantly. Then, without warning, the dreaded master warning light illuminates on your dash, signaling that the computer has put the vehicle into a fail-safe mode to prevent an electrical fire. Replacing that high-voltage pack is one of the most financially crippling repairs an everyday driver can face, completely wiping out any fuel savings you accumulated over years of ownership, and the system failure rarely stops at the battery. To keep all that high-voltage electricity stable, these vehicles rely on an inverter, which changes direct current into alternating current for the electric motors. This component creates an immense amount of thermal energy. To counteract this, the engineers installed a dedicated, separate cooling loop with its own electric pump. The piece they left out of the brochure is that these pumps have an incredibly high failure rate. When the pump stops moving fluid, the inverter cooks itself in its own heat within minutes. If you are driving down the highway when that happens, the entire drivetrain shuts down instantly, leaving you coasting across lanes of traffic without power. The manufacturer tinkered with a winning formula to chase a broader market segment, and the consumer is the one left holding the bill. You would think the truck market would be safe from this kind of corner cutting, right? Wrong. Truck buyers are fiercely loyal, and the manufacturers know it. They rely on that cult-like devotion to mask glaring drivability flaws. I regularly have owners of highly praised, late-model mid-size pickups come into my shop complaining about a vehicle that feels fundamentally broken. They describe a constant hesitation at low speeds, an annoying stumble when accelerating from a dead stop, and a transmission that acts like it is completely lost. When you take one of these trucks on the road, you can feel exactly what is happening. The transmission control module is programmed with an incredibly aggressive, deeply flawed logic loop, in a desperate attempt to squeeze out an extra fraction of a mile per gallon to satisfy government fleet averages. The computer constantly forces the transmission to upshift into the highest possible gear, dropping the engine down to a breathless, low RPM range. The moment you step on the gas to pass someone, the truck realizes it has zero power, hesitates, drops 2 gears violently, and lurches forward. It is an exhausting, non-stop game of transmission hunting that makes an expensive utility vehicle feel like a prototype that was never finished. The manufacturers released software updates to try and patch the issue, but you cannot program your way out of a bad mechanical philosophy. To make matters worse, these exact same truck generations frequently suffer from cheap component manufacturing on the assembly line. We routinely see them on the lift with premature rear differential and axle leaks. The seals responsible for keeping heavy gear oil inside the axle housing simply fail, allowing vital lubricant to weep out onto the brake components. It won't cause a catastrophic engine explosion on day one, but it turns a vehicle that claims to be a rugged tool into a high-maintenance headache that requires constant vigilance. The system wants you to believe that buying a vehicle is simple. Just trust the nameplate, look at the resale value, and trust that the engineers had your back. But the shop floor tells a completely different story. There is a clear, definitive line running right through the automotive world, separating the vehicles built by marketing teams from the vehicles engineered by actual mechanics. You need to know how to spot the difference before you drop tens of thousands of dollars on a lemon with a reputable nameplate. Because while the system is busy selling you overcomplicated, underbuilt disasters, there is a small list of absolute monsters hiding in plain sight. Machines so incredibly over-engineered that they practically refuse to die, even under the most brutal abuse imaginable. I am talking about vehicles with thick steel ladder frames, naturally aspirated power plants with zero turbocharger headaches, and heavy-duty cooling systems designed to survive conditions that would melt a standard commuter car. If you want to stop being a victim of the dealership shell game, you have to understand the specific mechanical combinations that actually deliver on the promise of immortality. And it all starts with a legendary power plant that was designed not for the suburbs, but for places where a mechanical failure means actual disaster. Here's the fix most dealers won't mention. They want you to believe that once these mechanical flaws show up, your only option is to sign over your life savings for a brand new factory replacement engine, battery, or transmission assembly. That is complete nonsense. When you understand the actual physical root cause of these failures, you realize that you can bypass the dealership monopoly entirely. You can correct the factory's cutting corners yourself, or instruct an independent shop to do it for you, often for a fraction of the cost. Let's break down exactly how we beat the system on these three specific problem areas, starting with that oil-starved sedan engine. The dealership will tell you that you need a completely new short block because the cylinder walls are compromised. In 90% of the cases that roll into my bay, that is a flat-out lie. The cylinder bores are usually fine. It is just the cheap, low-tension factory piston rings that have lost their spring rate and clogged with carbon. The real permanent fix requires swapping out those flawed factory components for updated, high-tension aftermarket oil control rings that feature wider oil return holes. To do this on the shop floor, we perform a top-end teardown. You pull the cylinder head, drop the oil pan, unbolt the connecting rods, and push the pistons out through the top of the block. Once the pistons are out, you clean the carbon out of the ring lands, install the updated aftermarket ring set, and reassemble the engine using heavy-duty cylinder head studs instead of the factory bolts. Why head studs? Because the soft aluminum threads in the block are notorious for stripping out when you try to torque the factory bolts back down. By switching to studs, you anchor the thread deep into the block once, and you never have to worry about the threads pulling out and causing a massive coolant leak later on. This is not a 20-minute driveway job. It requires precise torque wrenches, a piston ring compressor, a full gasket set, and about 12 to 15 hours garage time. If you do the labor yourself, the parts including the updated rings, head studs, and a high-quality gasket kit will run you right around $400 to $600. If you take it to an honest independent technician, you are looking at $1,800 to $2,500. Compare that to the $6,000 plus a dealership demands for a crate engine, and you see exactly why they keep this option quiet. I had a customer named Sarah come into the shop last winter with this exact issue. Her car was blowing through a quart of oil every 800 miles. The dealership told her the car was a total loss and tried to pressure her into trading it in for pennies so they could flip it. We did the top-end teardown, installed the updated high-tension rings, and repaired the block threads with heavy-duty studs. That was 40,000 miles ago. Today, her dipstick stays completely full between her 5,000-mile service intervals, and her total bill was less than a third of what the dealer wanted. Now, what about that bloated hybrid wagon with the failing high-voltage pack? The system wants you to believe that when the red triangle of death hits your dashboard, you are legally obligated to drop $4,500 on a brand new battery from the parts counter. Don't fall for it. A hybrid battery is not a single solid block of power. It is a modular assembly made up of individual cells wired together in a series. When a hybrid battery fails, it usually means just one or two cells have degraded to the point where they are throwing off the voltage balance of the entire pack. The fix here is surgical cell replacement and balancing, a process we call grid charging and balancing. First, you disconnect the high-voltage safety plug. Never touch a hybrid system without doing this first, unless you want 200+ volts running through your heartbeat. You remove the rear cargo flooring, unbolt the steel battery enclosure, and lift the pack out. Using a digital multimeter, you test the voltage of each individual module under a simulated load, like a heavy-duty headlight bulb. You will quickly spot the one or two rogue cells that drop below the rest. You don't buy a whole battery. You go online and buy individual, tested replacement modules for about $35 to $50 a piece. You swap out the bad modules, but here is the critical step the amateurs skip. You must connect the entire pack to a specialized tool called a grid charger and discharger. This tool slowly cycles the entire pack through several deep charge and discharge sequences over a 48-hour period, forcing all the individual cells back into perfect voltage equilibrium. While you have the pack open, you also pull the electric inverter coolant pump, which is easily accessed under the front driver's side headlight area, and replace it with an upgraded aftermarket pump that features a heavy-duty brushless motor. This prevents the inverter from cooking itself. The total tool and parts investment for this hybrid rescue is around $300 for the grid charger and modules, and about $120 for the upgraded coolant pump. It takes a solid weekend of focused work, but it completely revives the hybrid drivetrain and restores your fuel economy back to factory specs. Finally, let's address that annoying gear-hunting mid-size truck transmission. The dealership will tell you that the stumbling and hesitation is normal driving behavior, or a characteristic of the vehicle. That is code for, we don't know how to fix the software logic the factory gave us. You cannot fix a physical calibration issue with the same factory software updates. That's T failed the first time. The real fix for this drivability nightmare is a custom aftermarket engine and transmission calibration, commonly known in the enthusiast world as a custom ECU-TCU tune. Specialized automotive software programmers reverse engineered the factory logic loops and completely rewrote the shift parameters. By using a handheld flash programmer plugged directly into your vehicle's data port under the steering column, you overwrite the factory computer settings. The aftermarket calibration alters the shift points, forcing the transmission to hold on to lower gears slightly longer rather than rushing to upshift at 500 RPM. It also optimizes the direct injection timing to eliminate that low-speed throttle lag. This software modification completely transforms the vehicle. The constant hunting disappears. The truck feels immediate and responsive when you step on the gas. And because the engine isn't constantly bogging down, the physical stress on the drivetrain drops dramatically. The cost for a high-quality, reputable handheld flash tune ranges from $500 to $700, and it takes literally 15 minutes to plug it in and flash the computer in your own driveway to address the leaking rear differential axle seals on those trucks. You don't just put another cheap factory seal back in. You pull the rear axle shafts, clean the housing vents, which clog with road grime and cause pressure to build up inside the axle until it blows the fluid past the rubber. And you install heavy-duty, multi-lip aftermarket seals. Then, you extend the differential breather tube using a flexible rubber hose routed high up into the truck bed wall, ensuring water and dirt can never clog the system again. But before you run out to the garage, you need to hear this warning, because a common misconception can completely destroy your progress. The biggest mistake I see DIYers and cheap shops make is trying to cut corners on diagnostic testing. They read a generic code on a cheap scanner, assume they know the answer, and start throwing random parts at the car. On the hybrid vehicle, for instance, people often buy a cheap, reconditioned battery from an unverified online seller, only to find out the seller just slapped a coat of paint on a pack of mismatched, worn-out cells without properly balancing them. Within 3 months, the master warning light is back on. On the engine teardown, amateurs frequently try to reuse the factory cylinder head bolts to save $50. Those bolts are torque-to-yield components, meaning they are designed to permanently stretch when tightened down the first time. If you reuse them, they will snap or fail to clamp the head tightly, blowing your head gasket instantly and sending coolant straight into your combustion chamber. Do not trust cheap, unverified internet shortcuts, and never reuse single-use hardware. If you are going to beat the system, you have to be more precise than the assembly line that built the mistake in the first place. When you stop relying on the dealership's cookie-cutter solutions and take control of these engineering flaws yourself, the long-term transformation of your vehicle is staggering. By installing those high-tension aftermarket piston rings and heavy-duty head studs on your sedan, you are not just stopping the oil consumption for now. You are effectively resetting the clock on that engine block for another 150,000 miles. You protect the vital bearings and camshafts from oil starvation, keeping your internal friction low and ensuring that your engine operates at its peak thermal efficiency on that hybrid wagon. Surgically replacing the degraded cells and properly balancing the high voltage pack restores your fuel economy back to the high double digits you were promised on the window sticker. More importantly, it extends the overall lifespan of the entire battery pack by preventing the remaining healthy cells from overworking themselves to compensate for a weak link. And when you flash that truck's computer with an optimized shift calibration, you aren't just fixing an annoying driving experience, you are physically saving the internal clutches and bands inside the transmission from the premature wear caused by constant, erratic gear hunting. You are turning a vehicle that was designed to barely scrape past factory warranty periods into a machine built for the long haul. But executing the physical fix is only the first half of the battle. To truly maximize these benefits and lock in that legendary reliability, you have to establish a proactive maintenance routine that the manufacturers never put in the owner's manual. The generic schedules printed in those glossy booklets are designed to make the vehicle appear low maintenance and cheap to own during the first 3 years of leasing. If you want a car to last a lifetime, you throw those corporate schedules in the trash. First, for any gasoline engine, especially those known for oil rings clogging with carbon, you must switch to a strict 5,000-mile or 6-month oil change interval using a premium, full synthetic oil with a high-quality oil filter. The dealership will tell you that 10,000 miles is perfectly fine. It is not. At 10,000 miles, the detergents in the oil are completely spent, and suspended carbon particulates begin to settle into the ring lands, baking under immense heat until they seize the rings all over again. Additionally, you need to manually check your dipstick every single Saturday morning. Do not trust an electronic sensor or wait for a dashboard reminder. Make it a habit to see the physical level and color of the fluid with your own eyes. For your hybrid vehicles, there is a silent killer that almost every driver completely ignores: the hybrid battery cooling fan filter. This small intake vent is usually located underneath or right next to the rear passenger seats. Over time, it acts like a vacuum cleaner, sucking in pet hair, dust, and lint. When that filter clogs, the high-voltage pack cannot breathe. Operating a hybrid battery just 10 degrees above its optimal temperature range accelerates cell degradation by up to 50%. Make it a strict habit to pull that plastic grill cover off every 10,000 miles, vacuum out the debris, and wash the foam filter element. It takes 5 minutes, costs $0, and can save you a multi-thousand-dollar battery headache down the road. For the truck owners running a custom powertrain calibration, your maintenance focus shifts to fluid management. Because your transmission is now holding gears slightly longer to keep the engine in its optimal power band, the fluid is working a bit harder. Forget the manufacturer's claim that the transmission fluid is a lifetime fill. There is no such thing as a lifetime fluid. You should perform a transmission fluid drain and fill, not a high-pressure flush, which can dislodge debris and clog internal valve bodies, every 40,000 to 50,000 miles. At the same time, look under the rear end and check that extended differential breather tube you installed. Make sure it hasn't become kinked or disconnected during off-road excursions, ensuring the axle housing remains perfectly vented and free of pressure buildup. Now, I need to be completely candid with you about the potential trade-offs, because every engineering decision is a compromise. When you rewrite the rules to favor durability, you might lose a fraction of what the marketing teams used to brag about. For example, by flashing your truck's computer to eliminate transmission hunting and throttle lag, you are keeping the engine at a slightly higher, healthier RPM range during city driving. Because the engine isn't constantly bogging down in 6th gear at 30 miles per hour, you might notice a microscopic drop in your overall fuel economy, usually around 1/2 to 1 mile per gallon. Ask yourself this: would you rather spend an extra $20 a year on fuel, or drop $3,000 on a premature transmission rebuild because the factory software cooked the torque converter clutch? The system wants you to obsess over minor efficiency metrics while ignoring the catastrophic cost of major component failures. Don't fall into that trap. A slight calculated trade-off in fuel efficiency is a cheap insurance premium for absolute mechanical peace of mind. You see, the entire automotive industry is structured to keep you in a continuous cycle of debt and dependency. The manufacturers design vehicles with planned obsolescence, the dealerships pressure you into unnecessary upgrades, and the slick advertisements try to convince you that you are powerless without their factory-certified computers and proprietary components. They want you to feel overwhelmed by the complexity of modern engineering so that you blindly hand over your wallet every time a warning light pops up on your dashboard. But the moment you pick up a wrench, understand the physical components under the hood, and implement these real-world corrections, you break that cycle completely. You shift the power dynamic away from the corporate boardroom and right back into your own garage. You become the investigator, the truth teller, and the absolute master of your own machine. You now possess the insider knowledge to look past the shiny badges, spot the hidden flaws, and apply the exact engineering corrections needed to make a vehicle truly bulletproof. You don't need a dealership's permission to own a reliable car, and you certainly don't need to buy into their financial shell games. Take this knowledge, share it with your fellow enthusiasts, and apply it to your own driveway. Keep your eyes open, check your fluids, and never let a piece of corporate marketing dictate your financial freedom. You have the tools, you have the strategy, and now you have the absolute truth. Get out there, work smart, and let's keep these machines running forever on our own terms.